Predictive analysis. Predictive analytics are when you're using analytics to determine an unknown from a set of knowns. Wikipedia defines analytics as the discovery, interpretation, and communication of meaningful patterns in data. I think it's important to spend some time on those words, especially meaningful patterns. Meaningful patterns exist in most data. This shouldn't come as a surprise. If there's no meaningful patterns in data, then much of what we would see on a day-to-day basis in daily life would be haphazard and unpredictable. Often what we experience in life, though, is fairly predictable for us because there are patterns in what we see and that we recognize those patterns. And so meaningful patterns exist in most data. In the context of analytics, you're typically trying to establish meaningful patterns between independent variables and a dependent variable. If strong, consistent patterns exist in known data, we can use them to predict an unknown dependent variable with new and known independent variables. This is often done with different data sets, a training data set and a testing data set. The training data set is often used to train the algorithm or model on, and then the test data set is a different set of data that the model hasn't seen. The accuracy of the model is then tested on this new data. If the model is accurate, you can apply it to data for which the independent variables are known and the dependent variables not known. This is where the model gives you the prediction. One of the common misunderstandings is that people too often think that when it comes to predictive analytics, it's all about predicting the future. If you think of the opening definition where we talked about the fact that predictive analysis is trying to determine an unknown from a set of knowns, predicting the future is just one flavor of that. But the fact of the matter is that predictive analytics can be present tense as well. It's a common misunderstanding to think that it's only future-oriented. A second misunderstanding is that people think that when you're predicting, it can only be something that's numeric. The fact of the matter is that predictive analytics can be applied to both numeric and categorical data as the dependent variable that you're trying to predict. With categorical data, you're simply trying to predict a best category. The larger term that's used here is classification or categorization. This is where you have a bunch of independent variables and features, and based on those features, you're trying to predict a category that best describes those variables. This could be for the future, but it can be present as well. When you want to predict a numeric value, then you are trying to predict a specific value or level. A third misunderstanding is that people try to understand the underlying phenomena in predictive analytics. This is not the case. There are statistical procedures for that purpose, but when we talk about predictive analytics, often we're less concerned about explaining the underlying phenomena and relationship and more concerned with accurate predictions. The intention behind predictive analyses is that you're going for accuracy in the predictive modeling. In the end, we're trying to get better than just chance. So the better they predict, the more accurate, the more reliable, the better they are for us for use in real-world situations. In the end, the model with the highest accuracy is usually the best model. We need to talk about machine learning as well. One of the things you hear a lot these days in the terminology is machine learning. Machine learning is when you build analytic or statistical models, feed them information, and from there they're able to provide conclusions and outcomes. One good way of looking at machine learning is to think of it as a black box. You can't look inside the black box. Once you have an algorithm that is fairly predictive and reliable on an ongoing basis, then you can make it operational. It will then be able to recognize input that's coming in and make predictions on that. And based on how real life results compare to those predictions, it can, depending on how it's programmed, learn and further improve those predictions. One of the examples that you might come across is Microsoft's Azure Machine Learning Studio. This is software that allows you to create models in the cloud. Once you've created a model that is predictive, you can use other tools such as Excel to talk to those black boxes. It will then use Excel as the means of input and means of giving you back its prediction based on the information that you have fed to it. Another question that often comes up with predictive analytics is the question of how does predictive analytics differ from regression analysis? And the quick answer to that question is that regression analytics is just one form of predictive modeling. All predictive models have certain built-in assumptions with respect to what they expect of the data. One of the limitations of regression analysis is that it requires all independent variables and the dependent variable to be numeric. This means that your regression analysis is really good for predictive analytics when your situation meets those circumstances. Having said that, regression analysis is just one of many predictive models that are out there. And the predictive models can be used for both categorical and numerical outcomes as a dependent variable. Many other analytics models that are out there can use categorical numeric information and combinations thereof as dependent or independent variables. So there are lots of different options depending on the data you're dealing with, and each of them have restrictions and limitations. Understanding that is the key to saying maybe I should use this type of analysis because this is what is in my data in terms of numeric and categorical information. A few examples of models are decision trees, random forests, boosting, support vector machines. And again, many of these have both numeric and categorical information for dependent and independent variables. You can use a variety of tools to build end-user applications that model something and provide an end-user interface. R in itself as a statistical programming language does allow you to create a statistical model and then use a separate command to use that model on new data. Having said that, you can get much fancier than that when you start using Azure ML from Microsoft, where you can build a model in the cloud and then use tools to send the information and bring it back. Correspondingly, if you've got a really good black box and a very good predictive model, you can even develop web-based interfaces with such technologies as ASP.NET from Microsoft to develop web apps that use the black box that you've created. In the end, it really depends on the organization and the issue that's being addressed. You can have predictive models that can be used in real-time situations. These models have a constant feed of new information, and that's pretty deluxe. Or it can be standard and periodic data. It really depends on the question you're trying to answer and the form that the data is in. In terms of a predictive model in the organization, you would first confirm statistically you have a good predictive model. Once you've done that, you can build an application which can be anything from R to Azure ML to other tools. I hope this gives you a bit of an idea of what predictive analytics is, and equally important, how it can be used in the context of the organization and human resources part of the organization. The big question that remains is, what are some examples of predictive analyses that can be applied to HR? I'll give you just a few. Let's start with job classification. One of the traditional roles in HR is making job descriptions and determining what people need to be paid. Based on job descriptions, you can get an estimation of someone's responsibility and someone's pay. Job classification is a technique where you can categorize a job in terms of salary range. This helps you to professionalize your organization and to make sure that the jobs are being paid appropriately in your organization. You determine the salary range in terms of the job description and job responsibility. Another example is accident and injury data. In certain industries, data on accidents happening in the past can help you predict accidents in the future. The problem with accidents is that they endanger employees and it significantly can slow down the primary processes of an organization. This involves employee safety, reputation, and high potential costs. A third example we have talked about in this course is employee churn. As a firm, you can try to predict which employees are likely to leave and create interventions to retain employees that you don't want to see go. A final example is the job performance of new hires. Some predictive recruitment applications leverage historic performance data to predict job performance based on resumes, interview data, and other recruitment data sources. These are just a few examples. The list is limitless. HR analytics is quite novel, and there will be many, many more applications in the near future as people get more and more into this. If you have the data and the relevant variables and information, you can attempt to predict anything.